Now you've defined the two types of content URIs that the to-do list app will use to do things like insert and query data. The first type gives us access to a directory of tasks, and the second to a single task. And you've added constants in your contract class to help you refer to these URIs. But how does this all fit into how the provider works? The provider has to have a way to recognize the different URIs that are sent to it, and, based on the path, match it with specific data. So whether it receives a URI for a large directory or just a single row of data, it can interact with it correctly in each case. And it's up to you to code this URI recognition. One way to recognize specific URIs would be to look at the URI that's passed to your provider whenever data is accessed, parse it as a string, and see if that string matches the format for a directory or a single row of data. For example, you could write an if statement like if the URI string is equal to content://com.android.todolist/tasks, then you know that this URI identifies the tasks directory. But this becomes tricky when you want to check if a string has an integer ID at the end. And these statements can become really long and hard to read. But there's a better way to do this, with something called a URI matcher. It's the job of a URI matcher to determine what kind of URI the provider receives and match it to an integer constant, so that you can easily make a switch statement instead of using a series of long if statements that check for equality. Using a switch statement will make your code much more readable, and this will be easier to understand in actual code. So in our task content provider code, let's build a URI matcher so that it can identify the two types of URIs we defined. The first thing I'll do in this code is create the integer constants that these URIs will match to. I'll make these final int variables since we'll be using them throughout this code. I'll name one public static final int tasks and set it equal to 100. This will be the matching integer for the whole tasks directory. Then let's make another called tasks with ID equal to 101, which will match a single row of data in our table. It's convention to have integer constants for whole tables be rounded numbers, like 100, 200, 300, and so on. And for smaller sets of data in those tables, like single rows, they usually match to a related int, like 101 or 102 in this case. Okay, so we've defined integer constants for our tasks directory and for a single task. Now let's actually build our URI matcher and associate these constants with the correct URI. I'll be writing a helper function called Build URIMatcher to help me in this process. In this function, I'll first need to create a new URIMatcher object. I can do this by passing in the constant URIMatcher.noMatch to construct an empty matcher. Then I'll add the matches I want, which just means telling it which URI structures to recognize and the integer constants they'll match with. And I'll do this one by one, calling the addURI function. I'll use URIMatcher.addURI and pass in 3 arguments. The first is the content authority. The second is the path string. And together these two tell the matcher what exact URI you want to recognize. Then the third argument is the int constant that I want this URI to match with. So let's add the URI match for our directory of tasks first. This URI points to our tasks table. It has the same authority we've been using that's stored in our contract. And the path is just the name of our tasks table, which is also stored in our contract as path tasks. Then our third argument will be the int constant we defined earlier, named tasks, which is the value 100, and identifies this URI as the multi-row directory of tasks. And then we need to define the URI match for a second URI, for a single item. This follows the same structure as before, plus this hash symbol added to the path, which stands in for any numerical ID that points to a specific row in the database. So, as long as a URI has an integer after the initial tasks path, this matcher will recognize it and associate it with the int constant task with ID. These are the only 2 URIs we need the matcher to recognize, so to complete this helper function, you just need to return this complete matcher. You'll also want to declare this matcher as a global variable, named sURIMatcher. This is like a member variable, but starts with a lowercase s because it's a static variable. This way, you'll be able to access this URI matcher throughout your provider code, and don't forget to set it equal to the returned value of the Build URIMatcher method. And later, you'll need to refer to the matcher to deal with different URIs. For example, after creating the URI matcher, you can call URIMatcher.match and pass in a URI. The match method returns an int value, which will be the integer that you associated with the passed-in URI structure using the addURI method. And once you have this match number, you can write a switch statement to program different behavior for a match equal to tasks or to task with ID, such as deleting all tasks or just one. And if there's no match found, that means the URI is unknown to our matcher, and later we'll add code to handle that case too. The next quiz will give an example of this matching process.